So I'm going to be demonstrating how to develop a choropleth map. And an example of this type of map is shown here, where a user would be able to be interactive with this map. They can zoom in into a particular geographical location or zoom out and then be able to hover over a certain area in the map and it will display some sort of statistics. So if I hover over, let's say, for example, Texas, it will give me some information related to that particular state. Here we have information such as the state name, the identifier for the state, the region, abbreviations, and so on. But we also have the last part, the number of COVID cases during a certain time period, right? And this is representing, I believe, cumulative cases. And the way to build something like this is through a few library packages. And I'm going to show you these library packages in a minute. But there is going to be Pandas, Matplotlib. Those are going to be used in addition to a new library package called GeoPandas. And GeoPandas requires a lot of what they call dependency libraries in order for it to function. And I'm going to demonstrate what needs to be done to get that on your system so you can develop this choropleth map. This is just one example of what could be done. It really just depends on the data that you have available, the location data you have available. Here is an example of a state level type of choropleth map. And you can tell this is state level just based off of the way that you hover over each one of these regions. But even the line, you can see the borders outline each state. So we're going at this level. You can also do this at a county level where you get more information if you were to hover over each county in a state. That's possible, right? So we're going to take a look at how to develop one of these. I'm going to walk you through the steps. Keep in mind, a choropleth map it's a thematic map representing statistical data using shade or color mapping, right? And now I'm going to go to a link. All right. I want to demonstrate how to download the libraries that are going to be needed for geospatial analysis. We're going to be primarily using GeoPandas, but GeoPandas relies on other libraries. So in order for us to get GeoPandas to work, we'd have to first install that as well as the others. Now, I have this cell right here, which is the syntax that you'll need to use to do the installation. But if you don't have the installation on your Jupyter notebook, and let's say you're going to make use of GeoPandas and import the libraries, which is shown on this cell right here. If I were to try to run this cell, I'm going to get a no module, module not found error. And you can see the message right here. And that's just when the execution went to this first line. Now, if I uncomment the pip install GeoPandas and run that, it will work on installing GeoPandas for us. And then afterwards, we'll be able to use this. Now, that's just one installation, but we're going to have to do the dependency libraries next. But notice right here, we go to the bottom, it says successfully installed. So now if I go right here back to the import and then run that, it's now going into the next library that it does not recognize, which is Contextually. Now we do have Pandas, we have Matplotlib. These came with Anaconda prepackaged, but GeoPandas doesn't come with Anaconda. Neither does Contextually, and also a few other libraries. So the best approach here is to uncomment everything and that way, it will just first execute GeoPandas, install that, then it'll execute Contextually, install that, and then just go all the way down. So I'm just going to go ahead and run that. It'll probably recognize that GeoPandas is already there. Notice right here, requirement already satisfied. So it's not going to reinstall that, but now it's going to go down to the other dependency libraries that are needed. And it'll just go through each one of these individually. After that, once it's all done, then what you're going to want to do is comment out all of these pip installs, because this is something that you only have to do once. You will not have to do this again. So this is the approach that you want to take when it comes down to getting your notebook ready for geospatial analysis. So again, you could delete the cell, or you can just comment everything out, and then you're good to go. So I'm just gonna see if it's done. I do have a number right here next to the input line, so it did finish installing. So now I can go right here to the cell. Everything are comments in the cell. I can just run this to make that long log of installs go away. And then now when I go to the cell that has all the library imports, I'm going to run that, and the errors should not show up. Sure enough, it didn't. It executed just fine. So now I'm ready to tackle geospatial data. So this is the approach that you'll need to take first before you go off and start working with the data set related to GeoPandas. I want to work on retrieving this zip file, and this is a little bit different from what we've worked on in the past. We really haven't I would say load a zip file in Jupyter Notebook, and what I could do alternatively is I can get the zip file, put it on my local computer, and then try to retrieve it that way using other functions. But I went ahead and put everything on the cloud through GitHub just to make things easier for all of us to be able to load it and not have to worry about syntax errors when we're trying to load things on our local computer. So here's our URL where the zip file is located. You can see right here, the name is state geometry. We'll take a look at how the this GeoDataFrame looks like. And then here's that one library related to the files that we're going to be using, particularly the zip file. I don't need to go too much in detail with the syntax, but it's pretty standard that you would want to use if you're going to be loading data that is a zip file format. You can see right here, there's a data variable. We're calling that variable along with the syntax. And then eventually we are going to create a variable where we're going to be referring to it, but it's being assigned this function right here. So here we have gpd.read underscore file. Now you can see right here in the import statement, GeoPandas has an alias of gpd. So we're going to be referring to any sort of GeoPandas function using gpd. That means read file belongs to GeoPandas. The file variable is just related to the alias of the open data that we have here. Now, I do a type function to see exactly what data type the state shapes is, and then I also do a sample view of the GeoDataFrame. So let me go ahead and execute that. You can see right here, this is going to be a GeoDataFrame that is a little different from your normal data frame from Pandas. Now, here are the first 5 records that is popping up from the head method. Right? This is data that's coming from that zip file state geometry. And you can see we have information related to specific locations. We're focusing on the United States. We have state name. There's something called draw sequence. We're not going to be really interacting with that, but then there's state FIPS, which is a way to identify a region. Then we have subregion, well, what state or what subregion does a state belong to? We got the abbreviations, and then we have this, which is different from your regular Pandas data frame. So geometry is a column that is related to GeoPandas, and this is ultimately what is going to be used in order for us to build that choropleth map. And we have a column called geometry, and inside you can see the data points here. And If we focus on Hawaii, Hawaii has a multi-polygon type of shape, right? So this geometry column is letting us know the shape of each particular location, or in our case, in each state. So Hawaii is a multi-polygon, Washington is a multi-polygon, Montana is a polygon, all the way down North Dakota is a polygon. And the way that you want to think about this is when you're focusing on a particular state, there's a state that could have, just picture the border of that state. Sometimes there could be a piece such as like an island, right? Hawaii, we know there are different islands there. And if you want to get the border of Hawaii, you're going to see different islands being bordered, right? And thus this means that it is a multi-polygon type of shape. And then we have how it's being measured. In this case, it's in decimal degrees, and we'll take a look at different ways that you could refer to how things are being measured. But basically, we have a multi-polygon and all the different types of measurements related to the multi-polygon, right? Now, Montana, it doesn't have an island. It's not separated by any sort of water, and it's referred to as a polygon, and we have the shapes there. Now, it's a very lengthy record, so we're not going to see all the data points that is part of that polygon, but keep in mind these are all the measurements of a particular location. Okay, now since we are dealing with a data frame, a GeoDataFrame that we're referring to as state shapes, so the shape of the location, and these shapes we're referring to these as polygon, multi-polygon. There are certain methods that we can use in GeoPandas. One of those methods is the plot method, kind of similar to the plot method in Pandas, but this one, I'm going to show you. I'm going to hit state shapes dot plot, right? And all I'm doing here is calling the GeoDataFrame variable, putting a plot method, and we can see that it will project a map of the United States. I didn't really have to be specific in terms of what my X and Y would be to project this. Because this is a GeoDataFrame, the plot method will look for the geometry column and go ahead and project that as part of the output, right? And if you focus on each state, you can see the borders letting us know that we're looking at this state level geometry shapes, right? Now, this is a little bit different from other types of shapes. It really depends on the data that you're interacting with. So I'm going to go down and demonstrate how the county's shapes might look like. And so it's a little bit more detailed. There's a lot more borders involved. I'm going to go all the way down here, and where it says county level shapes data, I'm going to load this. And it's running. Here's the GeoDataFrame. But if you pay attention to this map projection, we have a whole bunch of borders, and these borders are representing counties. So we're going at a lower level type of detail here. Now, the choropleth that I showed you, it was a choropleth that at a state level, and that was using these type of geometry shapes, right? These multi-polygons and polygons. Right, so I'm going to continue on with this type of GeoDataFrame, and we'll go back to counties later. All right, now that is the plot method for GeoDataFrame. I want to talk about the CRS, which stands for Coordinate Reference System, and this is a way to measure, or it's a certain metric used when you are reviewing location data. Now, by default, when we loaded this, it's a GeoDataFrame, and the way that the geometry shapes are being measured, it's a specific type of CRS, and I want to call state shapes and use a CRS attribute. And when I do that, it's going to give me information related to the GeoDataFrame and its CRS, right? Now, the CRS that's being used here is 4269. Now, EPSG is something you don't really have to pay attention to, but it stands for European Petroleum Survey Group, and it was a group back in the past where they were able to do measurements on certain locations, and then they made that data available. So 4269 is one of those things that is being referred to in geospatial analysis. There are common types of CRS. 4269 is a very common one, and you can see this is the default for state shapes. Now, if you have location data that you're going to be loading, it might not always be 4269, so you'd want to check to see if there is a CRS, and there might be a different number. So another number that's very common is 3857, and 3857 is represented in a meters type of form. So currently we're looking at decimal degrees, and we saw that in the way that the polygons and multi-polygons are being measured. Now, there's some additional information related to the CRS attribute, but if I were to simply just wrap this in a print statement, it's only going to show me the CRS. Here's returning EPSG 4269. Now, I'm going to go off to this next cell and work on subsetting a particular location. I'm going to focus on subsetting Texas, and I'm going to view the data and then also plot that information. Now, when it comes down to plotting this, so we have state shapes. I'm going to call that GeoDataFrame. And I'm going to do a subset. So let me just go ahead and work on getting that data. And we're going to get Texas. Now, I need to refer to the column that contains the word Texas, or at least the abbreviations. But going back to this sample view, there is a state name column that I could refer to, and it's all in caps. So let me just copy that and go right here. I'm going to paste that. Right now, I'm not going to place this into a variable just yet. I just want to see if it's going to subset. All right, so there's something right here. I need to make sure I have the equality operator, and I'll run it. All right, so here's the subset for Texas. It's only one record containing information related to Texas, along with their geometry shape, which is a multi-polygon, because Texas does in fact have some islands. Now, I can go ahead and put this inside a variable. And then since this is a subset coming from a GeoDataFrame, Texas is going to be, that TX variable is going to be also a GeoDataFrame. So I can simply plot this and it will output just the Texas region. Okay. Now, what we see here are the X and Y axis. It's using matplotlib, and I'm going to make the X and Y axis disappear. If I say plt dot access off, and then I'll go ahead and do a plt dot show, we just have Texas right there without any sort of additional information, right? Now, that is how you would subset a particular part in GeoDataFrame. I'm going to do the same thing, but here I'm going to get Virginia. So I'll just copy this code that I did and modify it a little bit. I'm going to change the variable name. And then I'm going to change the string right here. So say Virginia, and I want to plot that. And let's see if this is going to work. All right, there's some off right here. It says empty, so I must have right here a typo. There you go. So we got Virginia as the output. All right. So I'm going to move on to the next part, and the next part is going to deal with changing the CRS. So if you recall, we used the CRS attribute and saw that we were dealing with a 4269, which is in a decimal degrees type of metric. And I'm going to go ahead and change this to a 3857. There is a 2CRS method from GeoPandas that I'm going to call. As a matter of fact, this is right here already written out. I'm going to just put the number 3857. And then also right here, 3857. So we'll see is we'll print out the CRSs before these changes take place. And then once they take place, we'll do the after. Now, I'm going to run this. And you can see the before shows 4269 for both, after shows 4269 for both. And that's because it didn't make a permanent change. If we look at the documentation here, And I'm just pressing, making sure that my cursor is inside the parentheses. Hitting Shift Tab will allow me to see this documentation. It does have an in-place parameter, so I want to make sure that I call that and make this true. So it will do a permanent change, and then I'll be good to go. I'll rerun it. And there we go. So now it's changed from 4269 to 3857. Looks like I'm getting, this is a warning, not an error. And that's because when I did a subset for Virginia and Texas, I didn't do a deep copy of this subset. And I went ahead and I made a change here. But I'm going to go back to the previous cell where I did the subset. I'm going to attach a copy method. So I'll make this warning go away and avoid any maybe sort of issues later on. So this is going to be located right here for Virginia. I'll attach a copy method there, and then I'll attach a copy method here. So I'll run that, and I'm going to run this again. And I'm going to go back to this part where we had that before and after, and I'm going to rerun this. Now we had that warning disappear, so we're good to go. And why would you want to change things from 4269 to 3857? It really just depends on what you're trying to achieve. Now, if you are interested in getting maybe the area of a location, it might be more meaningful to get the area in meters than in decimal degrees. And then perhaps meters can be converted into square miles. And so we'll look at an example of that. But since I did make the change of the CRS from 4269 to 3857, I'm going to open up another code cell just to demonstrate how this looks like. And I'll just type in Texas. And here is how the multi-polygon is being represented now. So it's no longer in decimal degrees. It's based off of meters. Now I am going to go back up and I'm going to copy this code. And this is code, let's see here. I'm going to go right here. And I want to print the contents. I'm going to delete this copy right here. I'm going to print the content from this subset. Now, this subset is coming from the original GeoDataFrame with a CRS of 4269, so it's in decimal degrees. And in this one, the Texas variable is where I stored it, and then I changed the CRS, right? And that is in meters. So let me go ahead and run this so we can see the difference between them. Now, it's a lot of data, so it's going to wrap around, but the first part right here is related to the first print statement, right? Now, focus on the geometry. We can see that at least that first data point, or actually we can see actually a few of them. We got 105, and it was in decimal points, 31, and negative 106, right? These are decimal degrees. Now, looking at the other part of this print statement, so this is the second print statement related to Texas. This is a multi-polygon in areas, right? So it's changing the format. It's still a multi-polygon. Now, since we do have Texas as a 3857, which is an area metric, I can go ahead and look at the area of this type of location. So if I call the variable Texas and put area, it's going to give us the area of Texas in meters, right? It's an attribute, so I'm not going to be wrapping around, or calling or entering parentheses. So I'm just going to type that in just like that. So this represents the area in Texas. It's a very large number, and that's why it's shown in this type of format. So this is in a scientific notation type of format. This could be modified by one approach would be using a Pandas function where you just basically run it once in the notebook, and it will modify, or it will just take care of the formatting from scientific notation to just a long format, the actual number. And that's what I have here in number 8. I have this function in place, and I'm going to go ahead and run this function. It's in memory. If if I were to go back here to number 7 and run this, it's going to show me the area in meters. All right, so this is the entire area of Texas in meters. I can do the same thing for Virginia, right? And it gives me the area for Virginia in meters, right? Now, we can see that Texas, right, obviously is larger than Virginia. Now, let's see here. Number 9, what I want to do here is use the distance. It's actually not an attribute. This is a method. I do mention that right here. So we're going to be getting the distance between Virginia and Texas. And this distance method is part of GeoPandas, right? And the way this works is you can go ahead and call, doesn't matter which one, I'll go ahead and call, I'll do Texas distance. And then in here, I'm opening up the documentation just to kind of see what's going on. I'm gonna type in the other variable, which is Virginia. Now, by doing this, it's gonna take a look at the geometry shape for Texas, which is a multi-polygon. It's gonna look at the geometry shapes for Virginia, same thing. And then it's gonna determine the distance between them. So here, okay, it looks like I got an, let's see. It says that the indices are different. Okay, all right, so I'm gonna go ahead and troubleshoot this really quick. Let me see what's going on. I'm gonna type in this, right? Oh yes, okay. So my code needs to be a little bit more detailed. It's not as simple as just putting Texas.distance and run. All right, there you go. So the distance between the two are, this is in meters. So what we can do is we can convert this from meters into miles, which is something, it's a metric that I would better understand. And if I go to this next code cell, it shows here that to convert from meters to miles, we have this type of formula. So 1 mile is equivalent to a little over 1,600 meters. I'm gonna use this code right here. We know that this code returns this value, right? I can go ahead and call this same syntax and divide that by 1609.34 and see what it returns. Right now, here this is this represents the distance in miles. I can always do a round function and just to work on the decimal points, right? And we got 761 miles, 0.44, right? I can also wrap this around a print statement, and this would be necessary if I had additional things I'm going to be outputting in this code cell. In order for me to make sure it's outputted, I'd have to wrap these around print statements, each statement that I want to output. All right, so we have this type of mileage. I can always go to Google and check to see what they're approximating the distance between Texas and Virginia. Now, the number is going to be a little bit different, and the reason behind that is because what's going on with this distance method, it's going to go ahead and pay attention to the from one border to the other border, whereas it's possible where Google is focusing on a particular part in Texas, like a center point in Texas, versus a center point in Virginia, right? Now, I've typed this in Google, and I think it's around like 800 or maybe 900 miles. We're looking at the distance between Texas and Virginia, but just know that you might encounter a difference, but it shouldn't be completely off. But from my research, it seems to be that this distance method is going from the closest distance from Texas and the closest distance from Virginia in terms of their borders. Okay. All right, so that is how you can combine meters to miles. It makes sense here. There is an attribute in GeoPandas that we can use where it'll give us the center point of a geographical location. And it's an attribute. If I were to call Texas in centroid, it's going to give me the longitude and latitude points. But this is also in meters. I can always change this into decimal degrees. But a point is a different type of geometry shape. So this is in the family of, we have multi-polygons, polygons, point is another one. And there's some additional ones. A point data type is going to involve this 2 coordinates, and it's going to represent the longitudinal first, and then the latitudinal point after that. So this is where the center point is in Texas. You can do the same thing for Virginia and check that out. Now, I'm going to move on to the next part. All right. So what I'm going to be doing here is I'm going to load a data frame, and eventually I'm going to work on merging the data frame into a GeoDataFrame. So the code that I want to focus on is here in line 5 and 6. Now this is going to be a data frame that contains reported cases of COVID-19. And this is data that's coming out of Johns Hopkins University. You can refer to this link right here to get the most up-to-date data. And I'm going to use a modified version of that data. I've modified it already before I started recording, and I've posted it on the GitHub. I'm going to be retrieving this data file right here. So this URL is going to be stored in this data variable, and I'm going to use that data variable under and call the read CSV function, get it stored here, and then view the sample of the data. Right? Now here's the data frame. This is not a GeoDataFrame, but there are some similar data columns here that we have in our GeoDataFrame. The columns, you'll have to look a little closely. The column labels might be slightly different, but the data points inside would be the same. And that's going to be really important to know when it comes down to merging. If you have columns that contain the same data, but the column labels are different between the 2 data frames, and there are different ways that you can approach this. You can change the names of the columns, or in the merge function, you can indicate the left data frame has a particular column name that's different from the right data frame. So that's the left on, right on attributes that merge function has. But we know that there is in the GeoDataFrame, there's a FIPS data column. It's not called FIPS. It's a little bit different. I can call this. Let me see how that looks. Where it's called state shapes. Right? Is a GeoDataFrame, and let me just call the columns right here. Yeah, state FIPS is what it's called. But the data points inside state FIPS is pretty much the same, formatted a little bit differently, but same type of values. Right? So there are some common columns that I'd be able to merge, but there's also state name, and we also have state name here. We're calling this province state in this data frame. All right. Now we are familiar with this data frame, but we have latitude and longitude. These are the location data provided as part of the data frame. We could try to see how this would look like if we were to use matplotlib and plot these 2 variables. Let me do just that, where I say plt dot I'm going to say plt dot scatter and df. And the way that you would want to project this is first use in the x-axis, you're going to use the longitudinal data, and then in the y-axis, you're going to put the latitudinal data, right? I'll do a plt dot show, see how that looks like. And it's going to go ahead and plot these coordinates for each record. And you can see it's starting to make out the shape of the US. There are some points scattered in different places. And the reason behind that is this is reported COVID-19 cases that are coming from US entities. So it could be states, provinces, it could be cruise ships that might have been outside somewhere and it's been recorded. So that's why we also might see some weird spots here. But there can also be some points that are just 0 in terms of latitude and longitude. You can see that right there. And if that is going to throw off your analysis, you can always remove them. It's not going to really have an impact on what we're trying to do here. So I'm just going to leave it as is. And I don't really need the scatter plot. I just wanted to demonstrate that you could plot this and see how it looks like. So when I'm viewing the data frame, it's going to show the first 5 and last 5 records. And we see that we have data related to counties. So admin 2 represents the different counties in the US. And we also have the province related to that county, their coordinates. We have the combined information here, the date they reported code case, and the actual number, right? Now I'm gonna just focus on one state and examine that data, right? Just to make sure that I understand what's going on. Looks like the date here is all showing November 13th, 2022 data. Doesn't look like there's any additional type of dates. So I'm gonna do a df dot province state. I'm gonna pull up Virginia and just view the Virginia data. It's all November 13th, 2022. At a county level, if I wanted to aggregate this to a state level, meaning when I'm looking at the records related to, let's say, Virginia, I want to get the total sum of cases. What I can do is call cases, and then it'll only, if I run this, it's only going to show the cases data, right? This would be a series, but what I'll do is I'm going to do a sum, right? Now, this sum is looking at all the counties in Virginia on November 22nd or November 12th, 13th, right? And all the counties in Virginia have reported cases, and we're going to sum them up, and that's this number right here. So this number represents the total number of cases in Virginia up to November 13th, 2022. And one way is to make sure that your number is valid is by going to Google and just checking what the COVID number is, the cumulative number for Virginia as of whatever date that you're checking. This is the data as of, or actually it's November 13th. It's not up-to-date data. Right? Now, if I were to tap into the original Johns Hopkins link, then I would have more updated data, and then I can run this code and see exactly if it is approximately similar to what's said on a Google search. Just double check, make sure that your numbers are correct here. All right. Now, what I'm going to do here is it says to aggregate data frame from a county level to a state level. I'm going to look at the data frame again. This is the entire data frame, right? What I was doing here, I was just looking at an example of how the data is being presented. And I know that this is at a county level. I can aggregate this to a state level where I use a group by method, and I can group by, let's say, province, state, right? And there I will focus my, let's see. Oh, yeah, I'm going to focus on cases. Let me just go ahead and put this, it's not really needed, but I'm going to put this inside brackets. If I want to add an additional column, I'll just separate it by a comma. I'm going to sum right here and see how this looks like. All right, there we go. So we have the states. Now, this is on the left-hand side. These would represent index values on a column of data. This would represent the total cases for a particular state. Now, I don't want this to be an index. I want it to be an actual data column. By default, when you use a group by, it's going to return a series But if I use as index equals false, right now it's going to return a data frame type of format, and that's exactly what I want. Right, and I'm gonna make use of this. I'm gonna call this states. The state data frame, where it contains all the states in their cases, is going to be placed here. And I'll go ahead and do a states.tail just to see how that's going to look like. And we're good to go. So I'm going to be referring to this variable, and I'm going to use this data frame to merge. I'm going to merge it with my GeoDataFrame, right? And that's what I'm going to do next now. I'm going to kind of keep these numbers consistent here with this section. It's number 1. This is number 2, number 3, and here number 4, and then we'll do this last part, number 5. Now, when it comes down to merging, I can use a merge function in Pandas, and here I'm going to refer to a left and a right data frame. So the two data frames that I want to merge, because Pandas and Pandas work hand in hand, I can go ahead and I'm going to call states shapes, which is the GeoDataFrame. And then I'm going to call states as a second data frame. Right? So the left and the right. My left is state shapes, right is states. State shapes is a GeoDataFrame. This one is just your normal data frame. And I want to make sure that the GeoDataFrame is placed first. So the left, or the first argument in the merge function. And that is because states will go inside to merge, and it's going to return a GeoDataFrame. So if I had it the other way around, if I had states on the left and then state shapes on the right, it's going to go ahead and do a merge, no problem, but it's going to return a data frame type. So whatever you put on the left is going to be that type it returns. Now, so if I run the merge, it's going to notice that there's some there's no common columns here, right? But I know that there are data points that are in fact common, but the labels are different. So that means I have to make use of the left and right, or left on and right on keyword arguments in this function. That means here, I'm going to say left on, I'm going to hit equal sign, I'm going to put some sort of column label name here. And I'll hit comma, and I'll say right on equal, I'll put some string value here representing the column name. And I'm going to, instead of having to rename these columns to have the same name, I'm going to investigate really quick state shapes column. So I can merge this using either state. I can use state name here, right? And let me open up just the state data frame and do columns here. Right? So we got province state that contains the state data. State name contains the state data. So those are common data points. We don't have FIPS in the data frame anymore because I did that group by, so it disappeared. But so then I'll go ahead and just merge them by state data points. So the left, right, the left one is a GeoDataFrame, and it's written as state name. The right is written as province, and it's case sensitive. Make sure that you type this in correctly. So we got that. I'm gonna try to run this and see what happens. There we go. Right now, this has not been saved to a variable. This is showing me how it would look like if I were to, in fact, put this inside a variable. And we have a merged GeoDataFrame where we got all the original GeoDataFrame columns, and then we have province, state, and cases being shown right here. You can match up Hawaii with Hawaii, Washington with Washington, and so on. Right now, this is going to be the main GeoDataFrame that will be used to develop that choropleth map, because we're going to make use of the geometry column to project the map. But then we're going to indicate that we want the different colors of the map to be based on the cases. So the larger the case, the particular type of color is going to be used for it. Right now, we're going to go ahead and develop that. But beforehand, I am going to I'm going to call this GDF for GeoDataFrame. And so all this content is going to be stored inside here. In order for it to be stored inside here, I need to rerun this. Right now, I know that it's inside this variable. It's always a good idea to just make sure that you just double check that the variable does in fact contain the data. And it does, so I'm good to go. And what I'll do now is develop that choropleth. And there's an explore that I'm going to make use of. I'm going to change this up a little bit. So it says data.explore, but that's an old GeoDataFrame variable that I was using before. I'm going to call this gdf.explore. So this is part of the GeoPandas. And then here, I've already written the code where it says column equals cases. So we're going to be focusing on the cases. Then I'm indicating a CMAP value. And this is where you can look into the documentation and see what kind of colors you want to have on your choropleth map. I do have legend equals true, and then the scheme, how I want my interval to be when it develops the legend. Now, I'm gonna go ahead and run this, and now I have my choropleth map, right? So here's Alaska. You can see that there is their cumulative cases is 298,651. And then we have, as we're hovering over, there's some additional columns being shown here in this pop-up. So if there are certain columns that you don't want to show as you're hovering, then you're just gonna have to subset the columns that you want to show as you do this right here, explore. So my GDF variable, which is this, contains all of these. And if I don't want to show, say for example, draw sequence, or FIPS or subregion or things like that, then I can simply just remove them or subset, and it will go ahead and display here, right? So that's how you develop the choropleth map. Here's the legend. It's showing the color code, and it looks like the lighter the color, the more or the higher the cumulative cases in a particular region, right? I can double click, right? This is an interactive, very neat feature. This is part of the Folium library that we also installed prior to getting started. And now, as I mentioned before, this is all like state level data. I won't be able to go into a particular county, though it is possible. But here is an example of a state level choropleth map. We do have a data frame here that contains county levels, right, from the United States. If I wanted to subset Texas from here, it'll only show Texas related data, but it's going to show me all of the counties in Texas. Now, that is assuming we're going to choose Texas to subset from this data frame, I would have to call the counties shaped GeoDataFrame, right? So here is the GeoDataFrame that is all related to different counties. So if we look at this GeoDataFrame, it's different from the state shapes. If you take a look at the column labels, we have FIPS, we have some shape length, shape area, we got the geometry, polygon, multi-polygons, depending on what you're looking at here. This is a sample view, but there is no name of the county. Right, so this is a GeoDataFrame at the county level. This is a data frame here at the county level, but there are common columns. We got FIPS, we got FIPS BEA, and because these are common columns, they should be able to merge. Now, I would caution you to try to merge the entire county shape GeoDataFrame with with the data frame here. Depending on your system might not be able to handle the load. It could be exhaustive on the computer. Your computer might freeze. Really depends on your specs. But to avoid that error, you can just focus on a subset in the GeoDataFrame, merge that to subset the data frame, merge into the GeoDataFrame, and then project the map. Right. So that'd be the approach to take when it comes there. All right. Thank you for watching.